Thanks to Dr. Jose Vega for his kind intervention in this presentation. Now, I kindly invite, especially, I say special, as a PhD student. He was one of the authors I read, and I never expected to find him in a conference in Bogota. Mr. Spiros Agathos, Dean of the School of Sciences, Life Sciences and Biomedical Engineering of Chaltech, Ecuador, Biorefinery from Nanomaterials. Dr. Agathos, please. I have to thank the organizers and above all Dr. Edgar Gonzalez for his kind invitation to this important venue. I'm especially thankful for being in Colombia for the first time, and I know that these countries, Ecuador and Colombia, also have many things in common, and we only can imagine and learn many things one from the others. I'm gonna continue in English with your permission. I'm going to I will continue with the theme of Alco Biorefinery and advantages of fresh talk about algae and idea of biorefinery from our colleague from Chile. Second slide. Recently moved to Ecuador to this new position, and in fact for those who follow the kind events of Ecuador, this is part of a very ambitious project changing the paradigm of having higher education and technology in intimate link with what we call economic matrix of a country. Yachay Tech is a university designed to be the first intensive university in Ecuador. It is situated in the area close to Ibarra city, 2 hours north from Quito, through the Pan American Road, close to the border with Colombia. And significantly, Yachay means knowledge or wisdom in Quechua language. When it is finished, in middle to longer term, we're going to have a span of 5-10 years, city of knowledge. This will in fact involve not only the university but also many research institutes and significantly small and medium enterprises and business incubators in order to really make what we call bioeconomy and circulate reality bioeconomy. Next slide. However, for purposes of this talk, I have to go back to my university of until recently my affiliation in Belgium, and this is the Catholic University of Urbane, Catholic University, where I worked for many years. I applied my bioengineering and microbiology and many occupations to transform scalable bioprocesses in technological systems, and along with 3 pillars. As you can see, many processes, biomolecular processes, similar processes. Today we're going to speak more about phototrophs and especially algae in a very good potential engineer biorefinery produced nanomaterials. So basic idea is starting from the objective of the production of industrial interesting high value biomolecules. Some of those have also been talked about by my colleagues from Antofagasta. We started rationally from strain characterization by a wide range of modern tools, biomolecular and other cell analysis methods, biodynamics, and different ways to identify metabolism. And the next group of themes is the conception of bioprocesses and its mathematical metabolite modeling, and approved, as we say in the pudding, the characterization of reactors, in this case bioreactors and bioprocesses. What you see here in the transformation from the algae, reddish or orange color, is for instance the process that upon a modulation of environmental stress that can lead from photosynthetic all the way to the prevalence of chlorophyll, all the way to the accumulation of antioxidants such as carotenoids, as mentioned before. Next one.
A very rich bio. I will also insist in all tones of the word that it is actually a tremendous resource because it is still underutilized. There is a huge gene pool. We have a wide diversity that is actually estimated based purely on genomic data to be greater than terrestrial plants, and significantly they have been adapted to wide range from saline, terrestrial, to freshwater environments, to hot and cold springs. I've been amazed, for example, couple of years ago, being in some of those salares up high in the Andes, in the Altiplano, and in the Uyuni area in Bolivia, close to Chile, to find whole lakes or pools that have different colors based primarily on the prevalence of the algae that exist. And these, again, represent a tremendous biodiversity waiting there to be valorized. Next one, please. Yes, well, again, this is only a survey, a very, very superficial one, but actually we are learning more and more based on the power of genomics and metagenomics these days, and we can actually start tracing back the origins to, in the virtual tree of life, of those branches that are, in fact, land-based higher plants that have evolved from green algae, those ones that the non-photosynthetic branches and groups that, in fact, may share some key characteristics, metabolic and otherwise, that we could learn about and then usefully go back by reverse engineering and look for those particular phototrophs that we are interested in. And finally, and most significantly, to keep in mind that those algal branches that I have indicated as 1 and 2 in the middle there are those that, for the time being, are mostly used in biofuel research. The next one. Again, it is amazing, and actually I would even say, a little bit tongue-in-cheek, but I really mean it, that it is a shame that it is basically less than a dozen species of algae that actually have been looked at in any level of technological relevance. Okay, so this means there is plenty to do, and hopefully we have the imagination, the tools, and the human talent to do more. Okay? Next. Okay, this is essentially the same information as I indicated before with respect to the priorities of my research group. And I will only repeat just this mantra, the couple of points, scalable and sustainable systems. Okay? Scalable and sustainable. Next one, please. Okay, so to come to the idea of
in fact, are hierarchical, and they can be utilized in both level applications and also biometric applications. You can see here this being indicated by these photographs. It would be interesting to check the tremendous potential of biogenic materials from biosynthetic organisms in different kind of opinion in biotechnology. One of them, of the main points, is the production and actually biogenic extrusion of kiting of nanostructures. Kiting, and the other simply shows we can learn about productions of metallic nanoparticles, silver or copper or both intercellular compartments and extracellular production. We can in fact adapt what we know about the biogenics approach by in fact introducing helpers in these processes. For example, APS through the diatom itself in order to modify macromolecules. This is in the level of hierarchical materials, and briefly I'd like to show 2 or 3 data from production of kiting, and demonstrated recently for the first time in a flat plate of a reactor. Why are we concerned about kiting? Because this is a biomedical material application. It is biocompatible. It is surface catalytic. We can in fact avoid eco-friendly approaches to have kiting from the usual sources, for example, crustaceans and shrimp. This is basically the same. Next one is, this is the device that we proved the production under control conditions. This is a flat panel airlift photobioreactor. This, well, I don't have time to show the several cultivation processes, but I would like to go directly to the conclusions and show directly. I'd like to, before that, I'd like to say that with 2 metasilicate pulses, we can reach, in fact, have good conditions of a controlled stress that allow a sustainable silicate stress. It produces sustainably kiting, which is 2 times higher compared to unstressed control. A side advantage is also the accumulation by at least 4 times higher lipids, and this represents 50% of the dry weight. You can see here nice structure of filaments of nanocrystal kiting. And simply, you need to keep in mind that often by the development of bioprocesses to cultivate translacera western flogi in a bioreactor, photobioreactor, PBR, this makes the recovery much easier, and can modulate the CO stress upon it obtain the totality of this at very high levels of kiting. Lipid content increases upon silicon stress. And kiting quantification. I have to acknowledge here the talented people in my group that helped me. I'd like to finish with these words, but I think this is extremely important. You can have any ambition in the world. Kiting, it's without human talent, without our students, without our collaborators, it is impossible. Of course, it is also impossible without appropriate support from funding agencies. I finished with this, and thank you for your attention.